Okay, I've done a lot of failed takes of this. So I'm going to do a lot of pauses in this video so if it goes all like bloop, bloop, bloop. That's why I'm just like pausing it so my brain can catch up so I can finally explain this correctly. It is honestly really simple once you get it. It's just kind of an abstract concept because it's just like not something. Anyway, let me just try and explain it. So this top one, let me do this. This top one here is an IPv4, a typical IPv4 address. 192.4. This is a typical IPv4 address for homes, right? So if you looked at your root at your IP address for your PC right now or your smartphone or anything at home, it would probably be something like 192.168.0. Something here. I chose 16 just for an example. That's arbitrary. But this would probably most likely be your IP address at home, your private IP address. And this would typically be the subnet mask that's accompanying it, right? Every IPv4 address has a accompanying subnet mask, right? And the subnet mask just tells it which part of the address is dedicated to the network and which part of the address is dedicated to the host. And all that means is how much space you have for other networks on your one network, and or how much space you have for devices on that one network. So this subnet mask, right? As you can see, it's 255.255.255.0. So if I told you that where the 255 stop, that's where the network, so they can basically the computer or the network communicates to each other by saying like when the 255 stop, that's when the network portion ends, and then everything after that, they're all hosts. They're all computers. I mean, if you're talking about a home setting, they're all your computers, they're your smartphone, because they all need a unique address, right? So your TV might be 192.168.0.14 and your PC might be 192.168.0.15 and your smart fridge might be 192.168.0.16, all the way up to 255. I'll explain why they go up to 255 in a minute. But all the subnet mask is doing is basically saying what part of this address is network, in this case this bit, because you see it ends here, and what part is host, and that's this bit. So again, if you were to look at the IP addresses of your home devices, your smartphone, your PC, your smart TV, everything in your home that's running off your router, they would all have this part the same. That part would be the same. This part would be the same. 192.168.0. blank, right? And they would all have a unique end number, like 16, for example, or 4, or 7, or 32, all the way up to 255. They use these addresses typically for the home because people don't usually have more than 255 devices that they need an address for in their home. So it's just the simplest address to have for your home address, right? The reason these go up to 255, okay, I'll explain now. So IPv4 addresses, all of them are 32-bit. So 192.168.0.7. This is just completely arbitrary. This is just an example. And this would have a subnet mask of 255.255.255.0. So this, just to repeat myself, I'm going to do a lot of repeating myself. I kind of have to just assume that you're brain dead Otherwise, it might come out confusing. So I'm sorry about that. So where the 255 stop, that's where it's telling you the network portion has stopped, this being the network portion, and the host portion has begun. So you can just keep putting devices on this part all the way up to 255. Hope that makes sense. The reason it goes up to 255 is because all IPv4 addresses, such as this one, such as this one, 192.168.0.16, they're all 32-bit in binary. And the reason they're all 32-bit is because they're 4 times 1, 2, 3, 4. 1, 2, sorry. 1, 2, 3, 4. There's 4 sections to it, and each section is 8 bits. So you see here, IPv4 addresses have 32 bits, 4 lots of 8 bits. 4 times 8 is 32, right? And the reason they're 8-bit is because this is the, so you see this, like, this is what, so you know that binary is just ones and zeros. It's just on positions and off positions. And just via on and offs, they can communicate different number sequences. So, for example, this is an 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sections here, right? And if you add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, it equals 255, right? That's the maximum number that an 8-bit portion can communicate. Because if all of these are on, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, it equals 255. It can't go any higher than that, right? So let's roll back a little bit. The way this will communicate 192, the first part of this address and this address, 192, right? It's going on here and then 0, 0, 0, 0, 0, 0, because 128 plus 64 is 192. That's what that equals. And then to do 168, it would be 128 plus 32, sorry, 1, 0, because 128 plus 64 would be 192 as we established before. So that's too high. We're trying to get to 168. So that's got to be a 0. But 128 plus 32 is 160. So that's got to be on, right? So we've got 8 left because we're trying to get from 160 to 168. So this has to be off because 160 plus 16 is 176. Too high. Plus 8, yes, that gets us to 168. So you see, if you've got a calculator, I'm doing it, it sounded so patronizing, because if you use a calculator, you can't do it in your head. Just trust me. 128 plus 32 plus 8 is 168, right? I'm literally trying to pretend I'm talking to a 4-year-old, by the way, so. Okay, so 128 plus 132 plus 8, 168. So all of these must be 0, because otherwise we'll go higher than the 168 we're trying to get to. Does that make sense? That's how, in binary, it's communicating these numbers. So if you remember before, all of these equals 255, right? That is basically why the subnet mask is saying 255.255.255. Whatever, you know. It's just saying that binary all ones followed by, one second. So a subnet mask is always binary 1s consecutively and then binary 0s to represent the host. So this 255.255.255.0, that specific subnet mask in binary would be 8 1s, 1, 2, 3, 4, 5, 6, 7, 8, because 8 1s in the binary equals 255. So it'd be 8 ones, 1, 2, 3, 4, 5, 6, 7, 8, another 8 ones, 1, 2, 3, 4, 5, 6, 7, 8, another 8 ones, followed by 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8, because it's 8 bits, 8 bits, 8 bits, 8 bits, right? 255, 255, 2550. So this is basically why